welcome back to my channel. So in the last video we had talked about exponential functions. So in this video I am going to discuss about logarithmic functions. What are those functions? So you may have seen something like this: log of ax equals b. So what does it mean? It means that if I write a to the power b equals x. So this is what it means. It's like the indirect way of saying that if I do a to the power b, which will give me x. So this is a log function, and a is known as the base. Now so let's see some of the examples to get a better understanding of this function. So if I say, let's find the log of 2 to the base 2. So we know that there's only one number, that will be 1. So if I write 2 raised to power 1, that will give me 2. So similarly, if I have to find log of 4 to the base 2, that gives me 2. So this function has a lot of use in engineering and advanced mathematics, which you'll learn in the near future. So here we can see 2 raised to power 2 is 4, and similarly if I say log of half to the base 2 is minus 1. So let's see the range of inputs that we can give. Range of inputs, or the domain of this function. So for that, let's make a graph here. So y represents the value of the function. This is positive infinity. This is the x, this is the value of the input variable. Right, so in the logarithmic function, the base cannot be 0. If I have log a to the base x equals y, so this base cannot be 0. A can never be 0, because anything to the power 0 is 1, so it's not a log function. Also, a needs to be positive, always positive. So using those rules, let's find the range of inputs, what we can get. So when a is greater than 1, so we get a different function, and when a is less than 1 but greater than 0, we get a different kind of a graph. So in this graph, I'll make when a is greater than 1. So the graph will look something like this. At this point here is 1 0. So this says that log 1 a equals 0. So this is the point. So for increasing values of x, let's say log of to the base 2 8 is 3. So we can see that if I keep on increasing the value of x, 16 4, here we can see that if I increase the value of x, the value of y will increase similarly. So looking at this graph, when a is above 1. So here the value is increasing and it is going towards infinity, right? So this is what the graph will look like. So what if when a is greater than 0 but less than 1? So the function will look, the graph will look something like this. So this is positive infinity and negative. So the graph is kind of opposite of what we had before. So here we can see that if when a is in between 0 and 1, let's say we have log of half 0.5 to the power 2, that gives us -1. And so how did you get that? So that is 1 by 2 raised to power 2 is 1, that means that 1 by 2 to the power -1 will give me 2. So similarly, if I write log of to the base 1 by 2 log of 8, that gives me -3. So here we can see that if I keep on increasing the values of x, similarly the value of y, the value of function will increase in the negative side. So it will be close to negative infinity. It will go towards negative infinity. That is what this line here represents. So if x is closer to 0, here if x is less than 1, then the graph is going towards positive infinity. So this is now we can say that the range of this function, the domain of log is 0 till infinity, but not including 0. That's why I've kept it in open brackets. So this domain means in the range of inputs that I can give in values of x. So we can only give positive values in x. So therefore the domain is 0 till infinity. Now what about the outputs or the range of this function? Now we have seen that the range ranges from positive as well as negative. So simply the range of outputs is from -infinity towards positive infinity. Now let's move on to some of the properties of logarithmic functions. So first property, we have properties. So first property is if we have log p times q to the base a, that can be written as log of p plus log of q to the base a. So similarly, using this above rule, we can write log of p square, which will equal to log of p plus log of p, which will be 2 log to the base a p. Now here we have a special type of log function called the exponential logarithmic function, that is log to the base e, any number x. So e is a number between 1 and 2. The exact value of e is 2.718, also e equals, this is a series 1 by 1 factorial plus by 2 factorial towards infinity. So it all, the series equates to 2.718. So we'll use this in the next slides I'll show. So coming back to the properties, we did log pq. Now we'll do the second property, which is log of x divided by y to the base a, so which is equal to log of x minus log of y, and the bases have to be common. So now also another property we have is using the exponential number. We have e raised to power log to the base ex equals e. Now this whole thing is equal to x itself. Now let's try to prove that. So we know that the range of log function is minus negative to positive, right? So but for this particular property to be true, the value of log e to the x to the base e should be positive. So that means x needs to be positive, and e is already positive because e is greater than 0. So now we can write y, let's say y equals e to the base log of x, right? Now if I apply, now if y is greater than 0, which means log of x is greater than 0, so y automatically will be greater than 0, it will be positive. So if I apply log both sides, I'll get log of y equals log of e log x. Now using the previous property, I had shown that here. So I had shown that log to the base ap square can be written as 2 log p. So here we can see that this 2 is a positive number. So when it is positive, it is possible to write like this, 2 times log ap. So any number log p to the power n can be written as n log p, provided that n is a positive integer. So coming back here, if log x is a positive integer, therefore which is proved. So if this is a positive integer, I can write it as log of x times log of e to the base e. So log to the base e to the base e will be equal to 1. So therefore log y is equal to log of x, which implies that y equals x, and y we had already put y as e raised to the log of x, therefore y equals x. So this is a little bit tricky, but not need to worry this. So therefore I have shown the clear explanation of how we get e to the power log of x equals x, because sometimes people don't show it and therefore there's a confusion behind this. So now you know why we write it like this. So I'll conclude this video here, and in the next video I'll be talking about the differentiation of exponential and logarithmic functions. So thank you for watching and take care.